Good morning, everyone. I am Dr. Sudeep Sidhu, and I'm a postdoc working with Dr. David Wright. And in the last 3 years, I have been working on nitrogen management on these enhanced systems where we have grazing as a component. So when I joined this program, I saw this opportunity that even within this resilient system where we have shown high nutrient cycling and tremendous improvement in soil properties and the root properties, that how can we further improve the nutrient management. So I started working on integrating several precision ag techniques to come up with an on-farm tool that can help the grower make a recommendation for in-season nitrogen application in cotton. So the first step of that is to visualize your field variability. So first, I would like to talk a little bit about the Veris system and how to use it to come up or to capture your field variability. And we have been using this tractor-mounted state-of-the-art equipment, Veris MSP3, which can capture electrical conductivity, soil pH, and organic matter on the go. This equipment, the first thing that we will talk about is the electrical filters. If you see where Maynard is pointing at, this is the setup with 3 electrode filters on one side and the 3 on the other. So these are used to measure continuous electrical conductivity at 2 different depths, at 1 feet and 3 feet of depth. The second measurement that is done with Veris is soil organic matter. So if you can look here, this is the dual wavelength optical sensor which uses red and infrared radiation to measure organic matter on the go. It takes 1 reading per second. So the third measurement that we get from Veris is soil pH, and this is the pH assembly where this scoop gets a soil from the field every 25 feet, and then this pH measuring assembly on top moves down and measures the soil pH on the go. Once the Veris is run, the next step is to collect soil samples from your field, and that data is used to calibrate the results from the Veris. And then you can upload that information on the website provided by Veris, where they can zone your field. And this mapping or zoning of your field doesn't have to be done in more than once in 5 years, and the charge is about 50 cents an acre. All right, so now since we know that how to capture the field variability, the next question is, okay, I know this section of my field is different than this section. The question arises, how much nitrogen does this section need versus this section? To answer that question, we worked on developing nitrogen calibration strip. So the way nitrogen calibration strip works is that after you have planted cotton, you apply an incremental rate of nitrogen that starts with your typical rate, starts with a lower rate than your typical rate that you apply for that particular field, and you can increase it on an increments of 15 or 30 pounds and keep applying nitrogen which is higher than your typical rate. For example, in this field, a typical nitrogen rate is 60 pounds. So our nitrogen calibration strip was designed where we had rates starting from 30 pounds, moving to 45, to 60, and to 90 pounds. And that was on top of the starter fertilizer. Then you come back at the time of in-season fertilization, which is about the squaring stage in cotton. You come back at squaring and you see your plant health. You can see it visually, you can see the differences visually, you can see a gradient in the greenness with different response to nitrogen, with different nitrogen rates applied in the nitrogen calibration strip. Also, you can use handheld instruments like an NDVI meter that gives you an NDVI reading, which corresponds to the greenness of the crop and the overall plant health. So once if you start looking at a gradient and at a particular rate of nitrogen, you hit that topmost peak, and after that your readings or your quality plateaus. So that is the fertilizer rate beyond which there is no more response to nitrogen. So that way nitrogen calibration strip helps you determine what your nitrogen rate should be for that year. Now about the nitrogen calibration strip, the question would be, how many strips do we need in each field? Well, if you capture the field variability, and as a grower you know that that section of your field, the soil type is variable or highly different than the other section of the field, or this section of the field has been, traditionally giving you poor yields, so you need a strip for that section and you need a calibration strip for another section. Now, do we need to have the calibration strip every year? The answer is yes, because the nitrogen availability to your plant, it's based on the soil properties, also based on the weather. How much rainfall did you get? What was the temperature? So how much organic matter do you have? So if you have warm and wet climate, the organic matter breakdown will be fast, and whatever nitrogen is available in the organic matter will be available to your cotton plant. And in that particular year, your nitrogen response in a nitrogen calibration strip will be at lower rates, not at the higher rates. So based on the information that you get from your nitrogen calibration strip, you see the actual response to nitrogen for that particular field for that particular season. Now, having said that, I want to show you guys that I am standing in the middle of my research plots, where the cotton on my right hand side got the typical 60 pounds of nitrogen that is recommended for this field, and the cotton on my left hand side received 30 pounds. So it's exactly 50% reduction, and this 30-pound rate was decided based on the nitrogen calibration strip, which was established right behind this camera. All right, so the implications of, what are the implications of nitrogen calibration strip or cattle grazing in all? So in Jackson County, typically for traditional cotton production practices, about 150 pounds of nitrogen is applied. Now, moving from a traditional cropping system to a grazed cropping system that we have been talking about, the recommendation for growing cotton is 60 pounds of nitrogen. Now, with integration of these precision ag techniques using various MSP3 and developing the nitrogen calibration strip to see the nitrogen response, we are further able to reduce that 60 pounds to 30 pounds at one location and to maybe 45 pounds at a different zone in the same field. So that is a huge improvement in terms of nutrient use efficiency.